I'm talking about something I didn't do here, but that's actually work of the past few years. I'm actually the maintainer of the OpenBSD Spark 64 board, and there's some interesting stuff in there that happened over the last couple of years. So, OpenBSD Spark 64 is originally started as the port of OpenBSD to Sun's UltraSpark architecture, which is sometimes referred to as sun4u. All the Spark architectures from Sun before that are also Sun4, but we had Sun4, Sun4C, Sun4M. Those are all supported by OpenBSD Spark, the 32-bit version. And there's also Spark Sun4v, which we don't actually run on because there's a fairly limited number of machines that actually were built. But OpenBSD Spark 64 was started by Jason Wright and Andy Dunghang. They're currently not really involved anymore in the project. That's why I basically took over as the maintainer of the board. A lot of work was also done by Art, and it's based on the original NetBSD code. But and that ran originally on UltraSpark 1 and 2 CPUs. I think support for the somewhat newer 2i and 2e CPUs that are found in the nice 1U rack boxes that started the .com boom from Sun. Was added a bit later, but that was the state when basically I joined the project. And that's actually the state that the NetBSD Spark 64 port is still in. They only run on machines, fairly old machines with those CPUs in it.
Cross compiler too.
Well, this might actually be one of the ports where they actually sometimes
don't share your
compile on the machines themselves. But okay. So I think the general hackathon 3 or 4 years ago, we actually got OpenBSD running on the, at that time, newest CPUs, the UltraSpark 3 CPUs that are found in many of the bigger Sun boxes. That was quite a bit of work because Sun had subtly changed and dropped a feature from the CPU that we relied on. Then there was also the issue with that those machines came with a lot of new hardware like PCIOs, bridges that had needed drivers to be written for them. And since there was not a lot of documentation on that stuff available, basically none, that was very hard work. Most of that stuff was actually still done by Jason. Last year, I actually added support for the UltraSpark 4 and 4 Plus CPUs. Those are actually only found in the really big boxes. I think the smallest machine that you can get, that you could get with an UltraSpark 4 CPU is a Sun V480, which is a dual CPU. Now it's a dual CPU box. Now it's supposed to be a quad CPU box. Yeah. And something we also did recently was actually, Sun is not the only vendor of UltraSpark or Spark 39 CPUs as they're called, 64-bit Spark CPUs. Also Fujitsu in Japan makes them. And actually they're so successful in that they're actually the only, that Sun now resells their boxes with the past CPUs because they have some trouble coming up with a powerful CPU of their own. And that's an interesting story because basically OpenBSD is the only open source operating system that runs on those machines. OpenSolaris runs on some of those machines, but there's still quite a large number of binary drivers that you need to actually be able to boot on them. Linux doesn't support them, and like I said, NetBSD is stuck in the UltraSpark 1 and 2 days. And porting OpenBSD to one of the Fujitsu machines was quite interesting. DLG let me play with one that he has down under. And the nice thing about all these boxes is that they have a LOM, so you can actually reset them remotely, which means that I could work on them on stuff without having to ask David to reset the box every now and then. But at a certain moment, the machine crashed and wouldn't come back up again. And I looked a bit at the diagnostics, and it says that there was a hardware failure. So I was very afraid that the box was blown up or something, that I seriously damaged it. And apparently, the only way to get it running again was actually to call Sun, get the support engineer out. He had to type in some magic commands to clear the fault, and the machine booted again. Sorry? Oh, yeah. So the nice thing about these boxes is that they're big boxes. This was an M4000, and you can actually divide that box up in multiple domains. And when I was playing with only one domain, where the other domain was running university stuff, production stuff. So luckily, I only crashed my domain, but unfortunately, to clear that fault, you actually had to power down the whole chassis. So we had also to take down the other domain. And these boxes are not cheap, and they're supposed to be have all these reliability features. So yeah, if you can fault one domain and have to reset the entire box, that's dubious. We've been told that they are working on a firmware update to actually circumvent this, such that you can actually clear the fault, or that it just doesn't fault. Yeah. And actually, the reason why the box faulted is hilarious, because apparently I was pushing bytes too fast through the serial port. The Solaris console driver has a bug, or perhaps it's a feature in it, but it only pushes one byte through the serial port at a time, whereas our code used the whole FIFO of the serial port, so you would write up to 8 or 16 bytes at one go into the FIFO, and it would push them out at the right speed, except that it didn't, then would hang the machine. Okay, but what I really want to talk about is the work I did to support OpenBSD on Sun's next generation UltraSpark CPU, the UltraSpark T1 and T2, sometimes also called Niagara. And the servers, Sun calls the servers that these processors are in cool threads servers. It's basically an entire new architecture called sun4v. The V stands probably for virtualization, because these CPUs have pretty powerful virtualization features. There's a new mode built into the CPU called hyperprivileged mode. Normal CPUs, or standard CPUs, typically have two modes. An unprivileged mode and a privileged mode. The privileged mode is what the kernel runs in, and the unprivileged mode runs the usernet stuff. So these CPUs introduce a third mode, a hyperprivileged mode, which is reserved for a hypervisor. And this hypervisor offers some services. You can request access to I/O. You you can request access to memory, etc. And this hypervisor allows you to actually subdivide the box in domains. A bit like what you do with VMware, except that well, VMware uses on some CPUs uses extensions that were later added to the Intel and AMD CPUs, but this is actually a much better approach that's built up, redesigned from the ground up. It's still a Spark v9 CPU, so all the user land will still run on it, but the kernel needs extensive modifications. What's unique about these chips is that on a chip there are many cores. The current generation has up to 8 cores, and each of these cores has also many threads. Most of you will probably know hyper-threading in the Intel CPUs. This is hyper-threading on steroids, because with hyper-threading you typically get 2 threads on each core. Here you get up to 8 threads on a core. The UltraSpark T2 is actually a system on a chip, so it has lots of stuff integrated on it. There's a 10 gig network interface integrated on it. There is a cryptographic accelerator integrated on it. And like I said, these boxes run a hypervisor, and the nice thing is that the hypervisor source is actually available. So it's not a complete black box to it. I have to admit that probably the version that Sun ships in its firmware is not exactly the same as what the source code is available for, because they don't release new source code whenever they have a firmware update. But it's better than nothing. And that hypervisor code is all, you can look at it, it's 90% is heavily optimized assembly. So how do these CPUs work? Basically, there is, if you look at a modern CPU, then access to memory is actually very slow. So in many cases, you execute an instruction, you get some data from memory, and then you have to wait. So what these processors do is, while one thread is waiting for memory access, it switches to another thread and goes execute instructions there. And like you can see, if you have only one thread running, the C is when it actually does something, and the M interval is when it's waiting for memory, either to write it back or read from it. So if you run a single thread on a modern CPU, it's basically most of the time waiting for memory. So if you, in that time, can do other stuff, you get much more performance out of it. Because you can use the idle time that you're waiting for memory to do something useful. Okay, so what did I have to do to make this all work? There's a file called lowcore, usually lowcore.s in every OpenBSD port, and it's the bit of code that most people actually don't even want to look at, let alone hack on. It contains all the low-level, very low-level kernel code, like the low-level interrupt handling code, the code handling page faults, and especially the Spark 64 one is pretty much unreadable. It took me, well, yeah, a couple of years to actually understand what's happening. I don't think I still fully understand what's happening there. One of the difficulties with the sun4v, the UltraSpark T2s, is that you have only 2 trap levels. You can see the trap levels sort of as if you have a game, you have lives. So whenever something bad happens, you trap, and you need some registers to run some code in to fix things up. The original UltraSpark had 4 of those levels, so I keep 4 bad things could happen simultaneously, and it would still be able to recover from it. The UltraSpark T2 only has 2, which means that I have basically, if 3 bad things happen at the same time, you're dead, and the machine either hangs or crashes. So, but you get some help from the hypervisor because it handles some of the very low level stuff that UltraSpark, the original UltraSpark, had to handle themselves. Luckily, the so-called register window traps are still there, which allows us to do a very nice security feature called Stack Ghost. If you're interested in this sort of stuff, you should certainly read up to that. There's a nice article about that. So we still have the nice security benefits that we had on the sun4v port. Once I had that code running, I basically had a tree that would not run anymore on sun4v. So I had to spend some time on actually merging those versions and make sure that we get a kernel that runs on both architectures. You generally want to do that because for the users it's a pain to actually have to install a specific kernel for a specific machine. Although that is what Solaris does. This means that now basically all Sun school thread servers are supported with OpenBSD. You can run OpenBSD on the bare box with one caveat, and that's that the onboard network interfaces on the UltraSpark T2 Plus machines are not supported. And that's because David has been slacking. So I had to write a bunch of new device drivers to support this, because the thing is all virtual. There's no real serial port anymore, but you talk to the hypervisor to put characters out and read input. So I had to write a separate console driver called vcons. The PCI host bridge is also virtualized. So instead of writing to registers on a chip directly, you actually talk to the hypervisor to read from PCI config space and configure that PCI does. That's actually quite nice because that means that when Sun creates a new PCI host bridge chip or integrates it on the chip itself, like it did for the UltraSpark T2, all the code that deals with the differences is now in the hypervisor, and that I don't have to write a new host bridge driver like we had to do for the schizo on the UltraSpark 3 machines. Also, there's a real time clock on it. I had to write a driver for that. You also talk to the hypervisor instead of talking to a chip that keeps the time. And then there are virtual network virtualization devices. I'll talk about those a little bit later. And there's also a virtual console concentrator. That gets me to the next bit. Because these machines can be subdivided in what Sun calls logical domains. So you basically can, if you look at, for example, an UltraSpark T2 chip, it has 8 cores and 8 threads per core. So that's basically 64 virtual CPUs that you see. And if you run OpenBSD on the bare box, you'll see 64 CPUs. Now, most operating systems, and OpenBSD in particular, have a bit of trouble of keeping 64-bit CPUs busy. So what you can actually do is actually subdivide the box and assign virtual CPUs. So you can, on the thread level, you can assign virtual CPUs to domains. You also have to split up the memory. You assign memory to different domains. And then you can, within the same box, can run multiple instances of your operating system, or even multiple operating systems, different operating systems. There's basically three kinds of logical domains. There's a control domain, which is the first domain you boot on the machine, and it can actually configure the machine, so divide the machine up. It has access to at least some of the hardware in the machine, so typically the disk and network devices, such that it can talk to the outside world. There's a second, and all the other domains are called guest domains. They are completely separate, isolated from the other domains. So it's impossible that you can attack one domain from the other. But they communicate to the control domain using virtual devices. There's a special kind of guest domain that's called an I/O domain, and that's actually a guest domain that has access to some of the hardware. So the control domain always has to have some access to the real hardware, but on some of the boxes you can actually assign real PCI slots to one of the guest domains, and then it becomes an I/O domain. The MMU integrated on the chip makes sure that domains can't access each other's memory unless you allow it, explicitly allow it. And the I/O MMU actually makes sure that domains can't access hardware that you've assigned to another domain. So where use of an I/O MMU originally was designed to solve the problem that Bob actually was trying to solve, where you have a 32-bit device with a 64-bit machine with memory high up. Well, one of the ways to handle those devices is make sure that the memory is not there. You push it low before you do I/O. But the Sun machines have this nice thing called an I/O MMU. You can actually program the I/O MMU, tell it, well, the memory that's high up in the 64-bit address space is actually visible to the device with a 32-bit address. That's optional in the original UltraSpark machines, but once you divide these sun4v boxes up, you actually have to use it. Communication between domains is possible. You have to pre-configure channels to do that, and once those channels exist, you can actually share memory between domains. You have to be very careful with that, because once you give the other domain access to part of your memory, you can't. It's difficult to revoke that control. So that bit of memory.
No, it's easy. Just send bytes too fast down the serial.
Okay. So running OpenBSD in an I/O domain offers some interesting possibilities. You have to run Solaris in the control domain, at least for now, because you need to be able to divide the box up, and there's no code for that to do that yet. And to do that, you need to install some special software for it. You can actually, some doesn't charge money for it, and I suppose the newest boxes come with it pre-installed, but the boxes I got didn't have it yet. And when you do that, you can simply boot OpenBSD in the domain, and if there's real hardware, then it can access that domain. So the first thing I got running was OpenBSD on my T1000, where I had put in an Ethernet card in the PCI slot, such that it could boot OpenBSD diskless on that machine. Unfortunately, the number of I/O domains is typically fairly limited. I think on the UltraSpark T2 boxes you can get up to 4 of these boxes, because those have four chips in them actually, and each chip has its own PCI bus. But it's usually it's only one I/O domain and one control domain. But you could do a very cool thing in there and assign a few virtual CPUs and some memory to OpenBSD and run a PF firewall in there, such that you can protect the Solaris running on the rest of the box. So here is the hardware that's in an Ultra T2000. If you see, there's the UltraSpark T1 processor in the top. It talks to a PCI Express host bridge, and you can actually you can split that host bridge. So you see to the left there is a dual gigabit Ethernet, and your storage, the SAS controller, is on that side of the bus. You probably have to use that for the control domain, but the right-hand side you can use can assign to the I/O domain. So you have on that machine you'd have 2 of the onboard gigabit Ethernet interfaces and a couple of PCI Express and PCIX slots. You also have the USB on that then and a serial port. You can always do useful stuff. So the next step was to actually try booting OpenBSD in a guest domain, so without access to real hardware. For that to work, well, I could already put a bsd.rd in that domain, but that's not particularly useful if I mean, it can't talk to the outside world, and you have no disk to install to, so that's really useful. So to do that, I had to write basically two drivers, a virtual network driver and a virtual disk driver. Sun defined some protocols for their logical domain software, published the specs for it. And they have in Solaris, they have a virtual network switch and a virtual disk server. So my code simply talks to those over an LDC channel. It works a bit like this. So if you have a kernel running on an I/O domain, you can use the normal driver to talk to your hardware. If you have a guest domain, you have to communicate through the hypervisor over a logical domain channel to the operating system running in the other domain. It then gives you access through its native driver to a disk, or alternatively it gives you access to a file on a files system and presents that at a disk. The communication can be pretty efficient because you can give the I/O domain access to some of your memory. So you typically pass it a bunch of pages of memory and a request for some data. The I/O domain gets the data, puts it in the pages, and communicates back through you over the logical domain channel that the data is there. So so the data itself does not need to go through that logical domain channel, which makes things The question is, of course, you still have to run Solaris on the other side, and do you actually trust it? And I'm afraid that the virtual disk server and virtual switch on Solaris side have bugs, and if you hit them, your control domain goes down, and it will take down the entire box. Okay, so the ultimate goal is actually to try and run OpenBSD on the control domain. So for that, basically what you need is you need somehow get access to the consoles of the guest domains. I already wrote that driver. There's a virtual console concentrator that basically it's another hypervisor interface. You can talk to the hypervisor and it then sends your data to the consoles of the other domains. And it works because I can boot OpenBSD in. I use Solaris to configure, set up the domains. Then I boot OpenBSD in the control domain. I use CU to access the terminal device of one of my guest domains, and I can see it sitting at the open firmware OK prom. I can actually type commands in there, and it all works. But when I try to boot OpenBSD either over the network or the virtual disk, it doesn't work yet because the virtual disk server or the virtual switch on the control domain isn't there yet. I am working on the virtual switch driver. We're still a bit debating on how to do this. Sun implements a real software switch, whereas our thoughts are that we simply present that as another network device in the control domain, and then use the OpenBSD bridging code and routing code to do smart stuff with that. That's probably, it's a bit more involved in setting things up, but it gives you, it makes things much more powerful. That sort of works in that I can actually boot a BSD.rd over the network that's sitting, that's accessed through the control domain. But once the kernel starts running and it wants to ifconfig up the interface, then things fail. So there's still some bugs to fix there. I haven't started the virtual disk server yet. I wanted to work on that on this hackathon, but I got distracted and was doing other things. And when that happens, you could run multiple up to 64 instances of OpenBSD on a single, probably 1U or 2U box.
Is there a chance that you will eventually be able to run Solaris as a guest?
Yep. In principle, I haven't tried that yet, but in principle, at that point, it should be possible to boot Solaris or should on Linux in one of the guest domains, because we as soon as we implement enough of the virtual disk and virtual switch protocols, that would work.
So Sun doesn't cheat, they really use the hypervisor protocol properly.
Yeah. Well, at least there's no way to cheat.
Yeah.
Because the hardware enforces the difference between the privileged and the hyper-privileged level. You have to. Solaris has to run through the same loops as we do.
Yeah, but maybe they have some other interface they haven't documented.
Well, there are undocumented. There's some additional logical domain channel setups to actually talk to the firmware. So these boxes all have a LOM, and these LOMs nowadays always have some sort of PowerPC processor usually in them. And actually they can talk to the hypervisor as well. So one of the things that hasn't documented properly yet, I'm not sure if they will actually do it, is the protocol to actually make the control domain talk to the
the service processor on the low, which will give you information about the sensors, the environmental information about the box and that sort of stuff. I think that was it. Any further questions?
Sounds like similar to Zen, the design of it.
Sorry?
It sounds quite similar to Zen.
Well, yeah, but Zen is
design, but it's pros and cons.
but the problem with that is that with Zen and VMware and all those solutions is that well, there are different kinds of virtualization integrated. So in the simplest case, there's no hardware protection at all. So if you find a bug in Zen itself, you can probably easily crash the what is it, the DOM 0 that they call it. The newer CPUs have some sort of hardware functionality that has some sort of hardware privilege level, but it's not completely separate. You still run the hypervisor on an OS, and if that OS has vulnerabilities, you control the whole machine. Whereas in this approach, unless you are able to find bugs in the hypervisor itself, or you're able to talk to the flash, wipe the flash basically where the firmware sits, you have no way to actually control the hypervisor. There's simply no way to do that. So it's not complete electrical isolation like on the big, really big Sun boxes like the E25K or 25,000, which you can actually configure, and it has hardware in it such that it decouples the hardware devices, and there's no electrical connection anymore between domains. So that's not the case here. But it is quite a bit more controlled than what's happening in the Intel namely world, Zen or VMware.
But wouldn't you find a bug in the control plane? Wouldn't you still be able to control all the virtual devices?
Yes.
To guesstimate?
Yeah, that's true.
Have you thought about running dual IO domains? And
Sorry?
have you thought about running dual IO domains? Because the LDOM software allows you to run control domain mixed with an IO domain in one, and then add another IO domain to
Sure.
make sure that runners redundancy is.
Yeah, that's a bit questionable whether you can in principle there's a way to set up two IO domains in a box, and then
Maybe soft-RAID can do it.
sorry, and make those make your guest domains talk to both those IO domains, such that they have two paths out of the box into the world, such that we have redundancy. There's nothing that prevents you from doing that right now. There's no special support in OpenBSD for it. But yeah, software can do it. If you have two paths, two virtual disks that are basically two paths into the same external disk, and you run software on it, yeah, you have a solution there. Okay. More questions?
Who else runs these things?
Sorry?
Who else runs, apart from Solaris and OpenBSD, are there any other operating systems that do this stuff?
FreeBSD says they do it, but I think their main developer on this is in jail right now. Linux runs on these machines, but I don't see any attempts to actually make Linux run on the control domain. They certainly can't talk to the virtual console concentrator yet, so in that sense, we are already more advanced. And of course, Solaris. But that's about it.
If there's no more questions, then thank you very much. We figured out the power situation. We have these issues with the power distribution here because the sockets on the wall doesn't have power, but there are sockets underneath the seats. So if you find those, there's power there and your laptop will survive.
Thank you.